All right, onward and upward, negative exponents. So when we divide like bases, we subtract their exponents. So for example, if we did x to the fifth over x cubed, we know our answer is x squared because 5 minus 3 is 2. How about if we had it reversed? X to the third on top and x to the fifth on the bottom, we get x to the negative 2. Well, I want to talk a little bit about that negative exponent and what it means. So, we have here a whole bunch of base 2, and if you can see, there's a pattern where the powers are going down by 1. And that's what I like about math. It's always a pattern. Let's see if we can figure it out. 2 to the fourth power is 16. 2 to the third power is 8. 2 squared is 4. 2 to the first is 2. And if you remember, anything to the 0 power is always 1. Well, this can tell you why. How did 16 get down to 8? We divided by 2. How did 8 get down to 4? We divided by 2. How did 4 get down to 2? We divided by 2. How did 2 get down to 1? We divided by 2. Now you can see why this comes after geometric sequences. So you can see that this was a geosequence where we were dividing by 2. So with that said, can you figure out what 2 to the negative 1 is? That's right, just divide by 2. It's 1/2. And when we take 1/2 and divide it by 2, it's 1/4. Remember Mr. Allenwick's little trick? If you want to take a fraction and divide it by 2, yeah, that's it, double the denominator. And hopefully you see some other patterns here. For example, 2 to the third is 8. And look what 2 to the negative third is. 1/8. Aha! So now do you see what a negative exponent is? So if I come back here and I bring back that old problem that we started the class with, x to the fifth over x to the third is x to the second. So what do you think x to the third over x to the fifth is? Well, we're still going to subtract and get x to the negative 2, but it's really 1 over x squared. So here's what I'm trying to teach you today. Any base that's raised to a 0 power is 1. Any base that's raised to a negative power means you take the reciprocal. Much like I did here. X to the negative 2, we took x and flipped it, and then it's still raised to the second power. Okay, so let's look at some examples. Simplify. Well, there's a lot of different ways to do this, so I'll show you a couple of different ways. First, we have to follow our laws of exponents. This is saying cube everything in that parenthesis. But you know what I like to do first? I like to get rid of the negative first. So let's handle the negative first. I know a negative means to take the reciprocal. So in other words, this entire numerator is going to go to the bottom in the denominator, because that's what reciprocal means. So that's all I did. That negative just said take everybody and put it in the bottom, leaving me a 1 on the top, and in the bottom is also this a to the 6th. So now I can just go back to figuring it out. Let's see, this says to cube everybody here. So if I cube a 2, I get 8, and a cubed. And this says to raise that to the 6th power, so that's a to the 6th. 1 is still up top. Now it's asking me to multiply, and when I multiply, I add exponents. So this answer was 1 over 8a to the ninth. All right, question 2. When I look at this, same thing. Let's handle all the negative exponents first. And that simply means flip them. Negative 64 can stay. X to the fourth can stay. But a to the negative 2 gets flipped. So that means a squared goes on the bottom. All right, 2x to the fifth can stay on the bottom. But b to the negative 4 flips, so it actually goes to the top. Good, now we're ready to clean this up. Let's change colors here. Negative 64 and positive 2 can divide out to negative 32. X to the fourth and x to the fifth, if I subtract them, I get x to the negative 1. I'm going to hold on to that. This b to the fourth and this can stay there. And this a squared can stay there. But I have that negative exponent again, and negative exponents mean to flip. So the negative 32 is allowed to stay in the numerator. This x to the negative 1 has to go down into the bottom denominator. And then b to the fourth and a squared can all stay in their proper spot. And if it makes sense here, if we take this a to the fourth, x to the fourth and x to the fifth, and expand it out, common sense wise, you can see this is 1, 2, 3, 4 x's, and 1, 2, 3, 4, 5 x's. So when I cross these x's out, see where that x really ended up being? In the denominator. Okay, number 3. Same thing. I like to handle my negatives first, so they're out of the way. The 3 is not being raised to the negative 3. Only the y is. So that y to the third gets kicked to the bottom. Okay, 2y to the negative 4. All of that is getting raised, so all that has to go up top. And z to the fifth. All right, let's just clean this up now. 3, 2y to the fourth. 2 to the fourth is 16. Y cubed, z to the fifth. I'm going to clean that up still. 3 times 16 is 48. Y to the fourth and y to the third cancel out to y, because 4 minus 3 is 1, and then z to the fifth. Let's get one more example here. Ooh, this one's a little different. Okay, they gave me a function, f of x, ooh, remember that, which is defined as 4 times 0.5 to the negative x plus 3 times 0.5 to the negative x, f of 3. Oh, I remember this. This is really my x value. So they just want me to put 3 in every time I see an x. Okay, so when I put 3 in for x, I get back, well, I like 1/2 instead of 0.5, but feel free to use 0.5. Huh. A little different here. There's no top and bottom, so how do I handle the negatives? Same thing. I flip. So I'm going to take this, and this becomes 2 to the third. Get it? I flipped this. That's what takes care of the negative. And then I still have raised to the third power. Flip this and I get 2, and I still have it raised to the third power, so this is kind of easy. This is 4 times 8 plus 3 times 8, which is 32 plus 24, which is 56. Or feel free to do that on your calculator. All right, so got my calculator up. I could have just typed this in. 4 times 0.5 raised to the negative 3 plus 3 times 0.5 raised to the negative 3, and voila, 56. Same answer I just got. All right, a couple more and we're done. I like this one. This is what, number 5? So number 5 says, I want to raise all this to the negative 1. Well, I'm going to handle the negative first. And that means I flip this. So everybody who's in the numerator gets kicked down to the denominator, and everybody who's in the denominator gets kicked up to the numerator. But aha! Wait! I still have some more negatives up there. They don't belong because they have to get kicked down to the bottom because they have to get flipped. So the 14 is allowed to stay up top, but the d to the negative 3 means there's a d to the third down bottom. Y to the negative 4th, kick it to the curb. It's got to go down. And then the 7, the a, and the b to the 4th are all welcome to stay exactly where they are. And when I clean that all up, 14 divided by 7 is 2. And then on the bottom I have an a b to the 4th, a y to the 4th, and a d cubed. Another way to have done that one was, remember, when you raise anything to the 0 power, when you raise anything to a power, you can just multiply. So I could have just raised all this to the negative 1. So 7 to the negative 1, a to the negative 1, b to the negative 4, over 14 to the negative 1, d to the third, because negative times negative is 3, and then negative 4 times negative 1 would be y to the 4th. And you see why I don't like to do it individually? I like to take big chunks. Because then this 7 would have to come to the bottom, a would have to come to the bottom, b would have to come to the bottom, 14 would have to go to the top, and then the d and the y to the 4th, and we end up getting the same answer. All right, careful on these. This is saying all of this gets raised to the 0 power, and anything to the 0 power is 1. But number 7 is saying only the x gets raised to the 0 power, not the negative 2. So I have this negative 2 times 1. So this final answer is negative 2. And that's a big Regents question. Knowing the difference between something like this and this. This answer is negative 1 because only the 3 was getting raised to the 0 power. This tells me the negative and the 3 get raised to the 0 power, so that answer is 1. Bye.